thing, but remember we said the absolute value of x could not be differentiated at x equals 0. So I wonder what happens when we plug that in our calculator. Let's see. So if I go to second catalog, then I hit log, and then I enter in the absolute value, so I got to hit catalog again, absolute value of x. What? Hold on. Okay, the absolute value of x, double parentheses, oh wait, not double parentheses, not yet, comma, we're going to evaluate x at x equals comma 0. I think I entered that right. Double check everything. Looks good. It gives me the answer is 0. So now we got to be careful, because now that you've figured out how to calculate the derivative evaluated at a point, and you go to take that AP Calculus exam, based on these calculations, it will spit out an answer. But we know that the absolute value of x is not, it's not differentiable when x equals 0. So in this particular case, it's not a bad idea. In fact, it's a very good idea to always graph the function. And so when I graph this function, I look at it and I say, well, there's a corner at x equals 0. It's not differentiable. And so you will, Mr. Adams, actually it is differentiable, because if I go into the trace menu and click on calculate and take dy dx at x equals 0, it spits out 0. No. The calculator is running a computer program based on numerical values. Okay? So what am I saying?
It's 0.
No, that's what I'm trying to tell you. It's not 0.
Because you can't take the derivative at a corner, right?
Right.
Oh.
So be careful with your calculator. Your calculator is a stupid box. It'll do whatever you tell it to do. And now if you have a newer calculator, they try to fix some of these problems. But you know, the 83 was like developed in the 80s, and yeah, so it's not perfect. So keep that in mind when you go to do the AP exam. You're going to have to memorize. You can't take the derivative at a corner, a cusp, or a jump discontinuity. Period. Does that make sense?
Why